Today we shall be talking about forecasting a regression model, forecasting of a regression model, or today we shall be talking about forecasting the independent variable. We shall be talking about forecasting the dependent variable. So meaning that we shall forecast a dependent variable and dependent variable which is y, and compare the forecasted dependent variable with actual dependent variable which is y, right? So we shall forecast a dependent variable which is y and compare the forecasted dependent variable with actual dependent variable, and if the gap between forecasted y and actual y is small, then we can say our forecasting is good. Then we can say our forecasting is good, meaning that forecasting error is small. What is called forecasting error? Forecasting error means gap between forecasted y and actual y. Okay, gap between forecasted y and actual y. And if the forecasting error is small, meaning that that particular estimated model, is good, meaning that the particular regression line is good. In other words, predictive power of that regression line is satisfactory. Okay, predictive power of that regression line is satisfactory if the forecasting error is small. Okay, so today we have the two variable you can see from here, one is X, one is Y, and our data is from 1980 to 1994. So here our data is from 1980 to 1994. That is our data. Out of this, we shall be using data from 1980 to 1990 for estimated regression line. And so meaning that here 1980 to 1990 we also can call it sample, right? From 1980 to 1990 we can also call it sample. Okay, and from 1991 to 1994 we shall be using data for forecasting. And from 1990 to 1994 we shall be using data for forecasting. So here what is happening, from 1980 until 1990 we shall estimate the model. What model? Regression model. And from 1991 to 1994 we shall be forecasting. That means only 91, 92, 93, 94. 4 years forecasting. And here all data are known, right? So we call it ex post forecasting, right? Here all data are known, so we call it ex post forecasting. Okay, so we are set so far. Now we can estimate the model gradually. So we have two variables, right? We can see. I open as a group. So this is my time series data from 1980 until 1994, right? You can see the time series data, right? And we can estimate the regression model from here. That we shall do now. I go to quick estimate equation, then I put the variable. Okay, but here actually here we shall be developing the autoregressive model. What is called autoregressive model? Autoregressive model is like this. Suppose dependent variable is y and constant, then x is the independent variable, y lag 1, sorry, minus, right, minus 1 is independent variable. Y is dependent, x is independent, y lag 1 is also independent. That means y has come as a lag 1 y. So this type of model is called autoregressive model or dynamic model. They are same meaning, autoregressive or dynamic model. So today we shall be estimating this dynamic model for forecasting. Okay, and so our model, how to estimate it? I go to quick estimate equation, y c x, y lag of 1 lag, right? So it has become dynamic model or autoregressive model, and the data we have planned the data from 1980 until 1990, right? So from 1980 until 1990 we shall estimate the regression line that we shall do first. Then from 1991 until 1994 we will forecast the model. Okay. So if I so everything is set, you see the method, least square method, that we shall be applying to analyze the data and so on. Okay, now we shall estimate this model. This one is a auto regressive model or dynamic model, and data from 1980 to 1990. It is already here, so I press OK. So this is the result of the estimated regression model, and the dependent variable is y. You can see from here, right? And we have two independent variable, right? And r square and the probability, right? So here this model, our plan is to forecast the dependent variable from this model. Okay, but the estimated model should be very good before forecasting. That means estimated model, the r square should be high, there should be no serial correlation, there should be no heteroscedasticity, and also residual should be normally distributed. Only then the model is ready for forecasting, but not before that. So meaning that in other way, when the model has no statistical error, only then we can use the model for forecasting, not before that. That is the normal guideline. And you see, for this particular model, X is significant variable, but Y lag 1 is not, but at least out of 2, 1 is significant. So we are happy about it. So what is the guideline? Normally, at least 50% variable, at least 50% independent variable should be significant. So that is the normal guideline to accept a model. So here, out of 2, 1 is significant. So we are happy about it. And R square is quite high, 73.71%. So we are happy about it. Then F statistics and corresponding probability, it is also significant. So we are happy about it, right? Okay. Then we check check the serial correlation, whether this particular model has serial correlation or not. Okay. Okay. View. I go to view, residual diagnostic, and serial correlations. So suppose here I take 2 lag, okay, and serial correlation LM test, observed R square, and the probability value 0.473, meaning that 4.73%, which is less than 5%, meaning that we can reject null hypothesis and accept alternative hypothesis. And what is our alternative? Our alternative is there is serial correlation in this model. In other words, there is serial correlation in the residual of this estimated regression model. So the model is not good. We are not happy about it right now because there is serial correlation. Okay, but we assume that this model has no heteroscedasticity, and we also assume that the residual is normally distributed. But there is only one problem, that there is serial correlations. Okay. Although this model has serial correlation, we shall still forecasting the model. So although there is serial correlation, we shall still forecasting this model to check what happens finally. Okay, this is done. Okay, but what we do before leaving this model, our model, we give a name of this estimated regression model, right? We better give a name. Suppose the name of this model, I put it here, name, you can see. I click name. Suppose the name I put as equation 1, right? The whole estimated model, it is equation 1. I give it as a name, right? And so I press OK. So so you can see it has come here like this. if you go to the work file, you can see the model, estimated regression model, right? Equation 1, it is saved already. We check from here. So this is our model, and it is equation 1. You can see from here, right? So on the basis of this model, we shall forecast the dependent variable, and the name of this model that we have just estimated is called EQ1, right? And it is in the work file. It is here, right? It is here, and this thing will stay there. So this is saved. Okay. Now we want to forecast this model having serial correlation, right? This model EQ1 has a serial correlation that we have already seen. Okay, I go to proc, not proc. I go to, okay, first I open this model EQ1, right? This is my model. I go to proc and forecast. Also it is here. You can click here directly. Forecast this model, forecast, click on it, and we choose the dynamic model, dynamic forecasting, not static. This time our method would be dynamic method. And forecast name, I better give a name. Suppose the name is EQ1 by YF1. That means what is happening here? It means that our model EQ1 would be forecasted YF1, right? So the model EQ1 would be forecasted into future, and our sample data should be from 1991 to 1994, right? Okay, and that means only 4 years. The forecasting would be only 4 years. Very small forecasting. Okay, and what I do, I deselect this one, deselect. That means if I deselect, meaning that there will be no actual Y. If I deselect, meaning that there will be no actual Y. Only forecasted Y or dependent variable will be shown, right? Okay, what I do, okay, I better here I change the name. Suppose I take it YF only, right? I better take it YF, right? Okay, so the name is YF and equation 1, right? So, and the equation is EQ1, right? And that we want to forecast, right? Okay, from 1991 to 1994, everything is set, right? Everything is set properly. Now I can proceed. I go to OK. So for only 4 years, right? 4 years forecast. Okay. So this one is the forecast of, you can see, forecast of equation EQ1, actual Y, only 4 years forecast. And what about all this thing? Root mean square, mean absolute error, mean absolute percent error, Thal inequality coefficient, and so on. Okay. So actually these are all called forecasting evaluation, right? These are called forecasting evaluation. And here, the smaller the value, better the model all the time. Okay, out of all this, we shall choose the root mean square error, right? And that is our benchmark, right? And smaller the value of root mean square, the model will be better all the time, right? That means the forecasting ability of the estimated regression model will be better if root mean square error goes down, right? That means the, yeah, so and you can see from here, this one is the forecasted value of the equation 1. Blue color, it is this one, right? It is the forecasted value of the dependent variable y, and the whole thing actually called 95% confidence interval. And this line is passing through 95% confidence interval, meaning that between two line, you see there is a there's two standard deviation line. The color is red, so it is passing through, right? It is passing through the 95% confidence interval. So the gap is called 95% confidence interval. So the our model, our forecasting is passing through it. So we are happy about it because it is passing through it, right? We are passing through it, so we are happy about it. And our root mean square is how much? 3.0141. Okay, so I better write it, our root mean square. So I better write it. Our root mean square is how much? Okay, and yes, I better write it here. I write it here. Our root mean squared error is how much? 3.014136, right? We can see from here, right? And smaller the value, better the predictive ability of this model EQ1. Okay. And here, root mean squared error is our benchmark to evaluate a model. evaluate a model, a estimated regression model. Okay, so this root mean square error, actually this one is for what? For equation 1, right? Equation 1, and we know that this equation 1 has serial correlation, right? Okay, now you can see another issue is coming up. This EQ1 and forecasted value has been saved already, has been saved here in our work file. You can see it has been saved. What is this one? EQ1YF. It means EQ1YF, actually the forecasted value of equation 1 having serial correlations, right? That is EQ1 already saved, right? Already saved. And here the value of root mean squared is 3.014136. So yeah, so again we come back here. Okay, so last time we estimated EQ1, right? Last time we estimated EQ1, and that was suffering from serial correlations, right? So now we shall remove the serial correlation and run the model again. So that is our model, you can see, right? I'm opening this model, it is already here, right? Okay, and our model was something like this. I'm putting in the estimate, right? So actually this model is suffering from serial correlation. How to remove the serial correlation from the model? So you have to put AR by 1. You have to add one more variable, and that is called AR1, autoregressive 1, order 1. So, and now I hope that the serial correlation will be removed from our model. So I estimate this model from 1980 to 1990. I estimate it. Okay, you see this is our new model, right? You know, so this is independent variable and it is dependent variable. So first this model should have a name, right? Should have a name. So I press name. Suppose the name is EQ2, right? So it is the new estimated model EQ2. Last time we did EQ1. EQ1, but now this time EQ2, the new model. Okay, you see the equation has become EQ2, and we have added this variable to remove the serial correlation, right? And here we can see R squared is quite good, 90%, 90.40%, and F statistics is significant. Now we check about serial correlation, whether it is there or not. I go to View, Residual Diagnostic, Serial Correlation, LM. So here I choose 2 lakh. Okay. You see Bush-Bregan-Godfrey test, LM test, observed R square. P-value is how much? 53.38%, meaning that we cannot reject null hypothesis. And what is our null hypothesis? The null hypothesis is there is no serial correlation, so we cannot reject it. So this model is free from serial correlations, and we assume that this model has no heteroscedasticity. We also assume that the residuals are normally distributed. So this model has no problem. This model is statistically sound. So this model is ready for forecasting because she has no statistical problem. Okay. Now we shall forecast equation 2, right? Equation 2. So, and you can see the equation 2 has been saved. You see, it has saved already, right? It is already saved, right? Equation 2 has been saved. Okay, equation 2 has been saved already, and we shall forecast this one, equation 2. Okay, so we proceed to forecast equation 2, and this equation has no serial correlation, but equation 1 had serial correlation, but equation 2 do not have any serial correlations. We shall forecast the equation 2, which is here, right? Open it. It is already open here, I guess. Yeah, it is already open here. Equation 2, right? And this is our model. We want to forecast it, right? I go to forecast, right? I go to forecast, and the forecast name I put it here as a EQ2 by YF. That means a dependent variable, which is Y, will be forecasted. The dependent variable, which is Y, shall be forecasted, and the data from as planned 1991 to 1994, right, that I choose, and I deselect it, and the method is a dynamic method. So now I think everything is ready. We can go for forecasting. forecasting, the model have no serial correlation. So I proceed. Okay. Okay. This one is this one, right? This blue line is this line, right? It is here. It is 95% confidence interval. And what about the value of root mean square error? You can see it is 2.76, right? That means the value has gone down, right? So we can check. So we can check from here. How to check? I'm just proceeding. We can check from here. You see, last time the root mean square was 3.014 for EQ1, but for EQ2 the root mean square has become 2.760659, meaning that root mean square has gone down. So what does it mean? It means that after eliminating serial correlation from the model, the predictive power has been improved, right? So that means we should always remove the serial correlation or other problem for forecasting a model. Okay, the question is that what is root mean square error? Root mean square error actually is actually a gap between actual y and forecasted y, right? So when the root mean square becomes big, meaning that the gap between actual y and forecasted y is big, so meaning that the predictive power of that model is not good. But when the root mean square goes down, meaning that the gap between actual y and predictive y goes down, so meaning that actual y and forecasted y, they move very closely, they proceed very closely. So meaning that our model is good, and because the forecasting has been very good. Okay, now you can check this forecasted YF has been saved already in the work file. That you can check back in the work file. So what I do, I go to the work file. You can see EQ2 YF has been saved. So what is happened here? EQ1 YF has been saved and EQ2 YF has been saved. And EQ1 YF actually the model having serial correlation, and EQ2 YF the model have no serial correlation. As a result, root mean square error has gone down. Okay, now we have we have EQ1, we have EQ2, and we have actual Y. So here are three things. EQ1 YF means here I'm saying EQ1 YF. This one is actually forecasted value of Y having serial correlation, right? Having serial correlations. And EQ2 by YF, this one is the forecasted value of Y having no serial correlation, and Y is actual value, right? Actual value of Y. So you can see this one, and this one. So what we shall do, these three we shall plot and check that whether they are moving together or not. And secondly, out of these two, which one is moving closer to Y? Whether this one or this one, which one is closer to actual Y? That we want to check. That is why we must plot it. So I'm going to plot it. First I open all the thing as a group. It is open already, right? It is open already. So this one is for the model having serial correlations, and this one model no serial correlation, right? And you know, these are only 4 years forecast, right? And Y is the actual value of Y. So what I need to do, I need to make a graph of these three things, right? I go to quick graph, and you can see we have three variable here: EQYF, EQ2Y, and Y. Three variables, right? You can see from here, three variables are here, and I shall draw the graph of these three variables. So the graph is coming up soon, and line and symbol I choose OK. This is the okay. What I do, I make it big so that you can see better. I make it very big. Okay, first I take it up gradually. I make it big, very big, right? I want very big. Okay. I don't know how big I can do finally. I'll try my best to make it as big as possible so that you can see better. The whole picture is coming up here. Yes. Okay. Okay. It's coming up. I think I cannot do more than that. Okay. Can I do more than that? Okay. Here is the story is something like this. Okay. Here you can see I think I have done the biggest size that I can do, right? I think it is the biggest. Can I make it further? Yes. I can make it further big, right? So big. Okay. This side. Take it up. Now it is okay. So here you can see this green line is actual y. This is the actual y, right? The green line, actual y, and the actual y from the from here to here, actual y is here, and EQ1 YF. So this one is the for forecasting of equation 1, and the color is some blue, right? Meaning that this one meaning that you see from 1991 until 1994, right? Only 4 years forecast. You see from here, right? And this one, the color is red, is this one, right? The red color. Okay. And the question is that out of these two, which one is closer to actual y? Out of these two, which one is closer? So from here we can see the line, the color which is red, the line which is red is closer to actual y. So meaning that EQ2YF is better than EQ1YF, right? So that we can see here very clearly that EQ2YF is closer to the actual y than EQ1YF, right? Why? Because EQ2YF has no problem, no serial correlation, no other thing. That is why the predictive power of the EQ2 is better. That is why the predictive power of EQ2 is better. That means the model EQ2 is better than model EQ1. And also we have seen the root mean square error of EQ2 is smaller than root mean square error of EQ1. That we have already seen. So now we shall be using this model, not this model, right, for our all statistical activities, for our forecasting and so on. Thank you very much for being with me for a while. You can see the terms and condition of this whole lectures. Terms and conditions, right? Whole lectures are here. terms of uses of the things, right answer 1.